All right. This video is going to talk about function writing. And now, so we're on week 8 of class. We've been using functions almost since day 1. And when we first introduced the idea of a function, we sort of said it's this pre-written set of commands in R that you're going to use to accomplish a certain goal. And we've been slowly learning different functions and how we can use them to help wrangle data and plot. So everything from read_CSV to ggplot to group by, all of these are functions written by someone in the R world that used the base functionality of R. And today we're going to talk about how and why to start writing your own local functions to make your coding easier. So let's start with a pretty basic example to just give you the foundations of function writing, and then we'll apply it to some of the stuff that we'll be doing or that we have been doing in class. So at a basic level, we start out doing some simple computation in R. Let's say, for instance, we want to convert temperature from Fahrenheit to Kelvin. So no one really knows much about this conversion. So you look it up and you say, okay, I take the Fahrenheit value, and let's start with, say, 75. Subtract 32, multiply by 5/9, and then add 273.15, right? So this is the conversion from Fahrenheit to Kelvin, taking 75 degrees Fahrenheit and turning it into a Kelvin number. But let's say you wanted to make this conversion on a whole series of numbers. What you'd find yourself doing is maybe something like this, where you'd copy and paste and be like, okay, but I also need to know, the value of 46, and then you'd run it, and then maybe copy and paste again, and you'd want to know the value of 49, and so on. So when you find yourself writing out a string of commands in R, and then changing one or two values, you're pretty much in the market for writing your own function. And the way we write our own function is a little bit meta. So there is a function called function for function writing. So even writing a function is based on a function someone else wrote, just getting into pretty deep R knowledge. So how does this function work? To start, I typically try not to think about the function at all. I first try to write out my set of commands, once or twice. And I ask myself, what is it in this string of commands that I change between every time I've copied and pasted? And in this case, it's this value here, which represents our Fahrenheit number. So the first step in writing a function is to identify what changes. And then this is your argument, or what we'll call our argument. And then you want to remove it from the code body and place into the function. So what does that actually look like? We're going to remove this 75, and we're going to replace it instead with an object name. This can be anything you want. Sometimes the most convention is just to call it X, but for right now, we can call it something that has meaning to us, right? So let's say this is the temp in Fahrenheit. We're going to call it temp F. And so now we've created this object inside our command that right now, if we run it, is meaningless because temp F doesn't exist, but we're going to use the function to make it exist. So let's call it, first of all, we have to give a name to our function, just so we give a name to our objects. So we're going to call this like F_2_K. So we're converting Fahrenheit to Kelvin. And then we use our assignment arrow and open up our function. So this is a function definition function. And what goes inside this function are the arguments that you would like to be able to iterate across. So in this case, it takes a second to wrap your head around that. But what I mean is that we need to take this value that we've sort of generalized inside our line of commands, and that is what's going to become a function argument in the function we're creating called F to K. So we've given it a name, we've opened up the function, we've given it an argument, and now we need to actually fill in the body of the function itself. And what we do is we just take this generalized bit of code with our argument inside it, and we stick it inside these curly brackets. And this is how we tell R, these are the commands that I want to happen inside the function. So when we press enter on this, you'll notice something popped up in our global environment, which maybe you've never seen before. We have all of these different objects and data frames and things, but then we now get our own function or functions category where we have a function with one argument called temp f. And so the way this works now is f2k function is now built into my computer, so you can start typing it, and you can see it pop up automatically. It's an object in your global environment, and you have to give it one value, which is that temp f value. So again, we could put in 75, just like we did before, but instead of copying and pasting the rest, it embedded it in this internal text, and now we get our output in the console. So this makes, for a pretty simple one-line set of commands, this is not as useful, right? But you can still condense a bunch of code to some different values and then continue to change the value and over again within the function that you wrote. Although in the next video, and next week, we'll get more into iteration, so how to iterate across this more smoothly, but we've now condensed this repeated line of copying and pasting down to a function. One thing I want to point out is this, it's just some vocabulary here, right? Which is what I'm going to call a pass-by value. And what I mean here is that well, actually, in this function, I specified it and it worked for now, but I'm glad I took this note, because typically what we do is we like to assign, when we are creating a function and using a set of commands, we often want to define a pass-by value, which is an object inside a function that will actually only exist inside the function. So I'll add it to here, and I'll show you what that means, which is that inside this code chunk, I'm assigning this converted value to k, but because it only exists inside the function, I then want to make sure I tell R, please return that value of k. So print it out when this function is done running. So I'm going to update my function here. I've now overwritten it, so it has this value k in it. And when I run this function, again, I get the same result in the console. And what I wanted to point out is that in my global environment, the value k has not populated, because that value k exists only inside of that function. And while in this really simple example, it actually didn't matter whether I assigned that pass-by value inside the function or not, it is important, usually in more complex function writing, which we'll see in the next one. And so it's important to write an internal pass-by value and return that value, but understand that that value will not be saved into the environment. It will only be saved when you specify it outside of the function environment. Okay, so let's now use an example that's a little more complex that helps us actually figure out, like, why would I want to do this? You know, why, like, copying and pasting this much code is fine, but it's when you find yourself kind of copying and pasting extensive amount of code and only changing one or two things at a time. So let's go ahead and read in our surveys data that we work with quite often. So here I have tried to read in my surveys data, but realized that I had not loaded in my tidyverse library. So I have my tidyverse library loaded in. I can read in my surveys data. And so now I'm going to just make a plot quite quickly as a way of showing you how we can iterate across plot making, or rather write a function around plot making. So let's say that I wanted to make a plot with just one of the species IDs in our data, right? So we have a good number of them, right? And let's just say for now, I want to plot one of them, and I'll plot the PE species type. So wherever that is, this guy here. So to do that, let's say I'll take my surveys data frame, and I'm going to use the filter function because I want a specific value from a certain column. So I'm going to say species equals, in quotes, PE. And also because I'm plotting and I don't really want to have to deal with NAs right now, I'm going to filter out my NAs in weight because I know that's what I'm going to plot. And I'm going to filter out my NAs in hindfoot length. Okay, cleaned up the data a little bit, and now I can pipe right into ggplot. I'm going to set my X value. So I'm just going to make a simple plot here, or a simple scatter plot. So I'm going to assign X to weight and Y to hindfoot length. So two continuous variables, which means I'm going to add something like a geom jitter, like I want a point. Let's add a few just fancy pieces in here. I'm going to make alpha a 0.5 so we can see through those points a little bit. I'm also going to add some labels. I don't know that we actually talked about this in class, but it's good to know that this labs layer, just if you really want to start making a cleaner plot with axes names that are better than your column names, for instance, you can just rewrite those. Talking while coding, you can rewrite them with the labs function where you just have x equals, and that will be your x-axis, y equals in your y-axis, and title equals, and I'm going to say, PE, because that's the species weight times hindfoot. I'll throw in a theme there to look professional, and we'll say, okay, I made a plot, and this plot is a subset of the data. It's only for PE. Now we can make, we've learned how to use faceting to make lots of plots at once, but there are circumstances in which you might not want to facet. You might want to actually make individual plots at once. So if you weren't, interested in writing a function, you might find yourself saying, okay, well, I want to make this for a bunch of other species. And so instead of, you might just say, okay, well, I'll copy it and I'll just replace the bits where I called out PE with other species types. So let's say I also want to make one for PL. I'll go in and I'll say, okay, where have I specified PL? I specified it in the filter and I specified it in the title. Then I'd run this. And then you're like, well, I also want to make one, for instance, with, maybe I want to make them for all of the species of a certain kind. And so, okay, let's say I want to make it for SH and then for SH and over, right? And this works. And if you get to this in class, like if you get to this point where you know how to make the graphs you want to make, great. But when you also get to the point where you're tired of copy and pasting, you're tired of, you've copied and pasted 30 times and you realize you want to make one edit, you have to go back and edit all 30 copy and paste, it just becomes a bit exhausting. This is where you might say, okay, maybe I could write a function for this. So these are a lot longer code chunks. It also makes some more sense. But following this principles of how would we write a function is I typically start with the code itself, right? So nothing fancy. We know how to write this. And I ask myself, what is it that I change every time that I copy and paste? It's this value here, the species value, and it is the title, essentially. So we're going to replace these values with our argument words, and this can be whatever we want. And so that I can find them more easily, I sometimes put my arguments in all caps. So this is going to be species, right? So I'm going to specify my species, and this is going to be plot title. So it's species and plot title in all caps, and R is case sensitive here, that are going to be my arguments in my function. So I'm going to call this like my plot function, something generic. So I've given it a name. I'm opening up the function. And remember, inside the function, the two things that you put are whatever you decided to name these objects down here, species and plot title. So this one now has two arguments. So the more things you want to manipulate in here, you can add more and more arguments into your function, right? This is your function. You can do whatever you want with it. You just need to keep track of what it is you mean to be manipulating. So we've specified that. We can then put this into the function brackets itself. And before we assign it to an object, we can see a little bit about what it does if I don't assign it to an object. So let's see how this goes. Let's say, okay, I've made a function, I've run this. So now I internally have a function called plot function. And I say, okay, let's see if it works. I open up my plot function and I know that it has two arguments. It has species and plot title. So let's try to make one we've already made. Let's go with SH. So you can fill this in almost as if, you were putting that species ID filter. So in quotations, SH. And then your plot title can just be SH weight by hindfoot. Right? And let's see. Did that happen again? Okay, that happened again. Cool. So we still have not proven my point as to why you need to assign objects inside functions. And I think it's actually more important for iteration in our next lesson. But so for now, we are going to say plot, just to kind of play around with this. What happens if I do plot and return plot into my function? And I'll change this to PL for now. So let's see. I'm specifying this return in the plot function, and return still works, so we're happy. I'm also going to change this to print because I know this will be useful for us next. And I want to print my PL function. Why are these changing a little bit every time is a decent question. Actually, that's a fun thought experiment to leave you on of why are these changing a tiny bit every time that I print them, even though they are the exact same plot, and it's not a mistake. So you can think on that. But okay, so we've now identified how to write functions. We know the basic architecture, and hopefully we're starting to see the point, right? So now instead of copying and pasting all of those different ggplot functions, I can now, or yeah, rather those ggplot lines of code, these 6 or 7 lines of code, I can put it only one time into a function. And then all I have to change are the arguments as they change. That way, if you want to add something, like a color, let's say you actually want all of your things to be blue. Well, I ran that with my cursor inside these brackets. And so it tried to read the function as if I was trying to execute it as opposed to setting a new function. But so let's say you want to change one thing, such as making the points blue. Now I only have to change that once, and then it will easily apply across anything I put inside that function, instead of scrolling back up and then going and trying to reassign the color argument inside every set of code. So I'm going to leave you there. The next video is going to be on iteration, where we're going to talk about how to move through these values even quicker. And we will talk more about it in class.